Hey, welcome back to Math with Patrick. Today is March 3rd, and we have problem number 62 from this Daily Epsilon calendar to try to solve together. All right, so we have three fractions, and when we add up all three fractions together, we apparently get the number 3. So I guess first things first, let me just rewrite the problem, and I'm going to make sure that all of my numbers are in the same line together. So I have 1 over log base 100 of 30 plus 1 over log base 10 of 30 plus 1 over log base 27 of 30. Okay. And as is, this seems like a pretty tough problem, honestly. So just going over the meaning of what a logarithm is, let's take a look at this middle one. This is asking 10 to what power gets me to 30. Well, I know 10 to the power of 1 is 10, and 10 squared is 100. And so 10 to the power of, well, it's going to be somewhere between 1 and 2, maybe like a 1.5. Now, I have no clue what this number is. I know it's between 1 and 2. Maybe I could get closer and approximate it with a decimal, but it's going to be some long decimal. It's not going to be this easy to just say, like, oh, 1.5 and call it good. So I'm not quite sure how big that is. I mean, this one's going to be between like 1 and 2. This is asking how many 100s do I need to multiply together to get to 30. And you don't even need one whole 100. So this one's going to be between 0 and 1. And this one asks how many 27s do I need to multiply all together to get to 30. And it looks like I need just barely more than 1. So this one is about a 1. So I can kind of see why this is going to be the number 3, because you can imagine this is about 1/2, this is about 1.5, and this is about 1. So adding them all up is going to get me, well, hopefully 3. Now, unfortunately, just kind of rounding and estimating is not good enough. One thing you could try to do with logs is when their bases match, like say we have like log base 3 of 9 plus log base 3 of 27. There are some log rules that are useful when your bases are the same. The base is this bottom number here. I can show you. So this is saying how many 3's do I need to multiply to get to 9? That's 2 of them. And this is asking how many 3's do I need to get to 27, again, in a multiplying way. And that'll be 3 of them. So overall, this is just a 5. And one thing you can do with logarithms, again, when their bases match, is if you have a sum of logs, you can make a log of a product. So this right here is a valid step you can take with logarithms. And I can just show this to you. If you multiply the 9 and the 27, that's going to get you to 243. And now this is asking you how many 3's do you need to multiply all together to get to 243. And that's going to be 5 of them all together. So this is a really great log rule, but it's not great for right now because none of my bases are the same. And I was a little stuck on this, but I think there's a good thing to do here, which is the change of base rule or equation. I don't know what to call it. Well, you can change the bases on logs too. If we have like log base b of a, you can rewrite it as log of a over log of b. And the cool thing is that the new base of this new logarithm could be anything actually. Well, okay, maybe not like 0, that wouldn't make sense, or maybe not 1. But like it could be like log base e or log base 10. It could really be anything. And I want to use this change of base rule to help rewrite some, or actually all of these fractions. So I'm going to have 1 over log of 30 divided by log of 100. And again, with this change of base rule, it's really convenient because you can pick any base you want. So I'll just leave it like this. Well, let's assume log base 10. And then if I need a better base for the algebra steps later, I can pick any one according to the change of base rule. So this will be log of 30 over log of 10. And this will be 1 over, let's see, adding the fractions, log 30 over log 27. And when you have these like fractions within fractions, you can essentially just flip this denominator, like 1 over 1/5. This says how many fifths can fit in a 1, and that's the same thing as, well, 5. So hopefully this is enough of a proof where if you do 1 divided by a fraction, you're allowed to just flip the top and bottom. So I have log 100 over log 30 plus log 10 over log 30. And this is kind of nice because I'm getting this common denominator on the bottom. And then log 27 over log 30. And like I said, I can kind of choose whatever base I want in the end. Let's just assume log base 10 for now, but then maybe I'll want a different base for, if it helps me out. So I said common denominator. So let's just shove all three of these fractions together because the denominator is the same number. And earlier I was talking about that log rule with sums, where if I have the sum of logarithms, I'm allowed to multiply all of those arguments all together and do the log of a product. So I'm going to do 2 steps at once here, and I'm going to do log of, and then 100 times 10 times 27. Hopefully this is the number 3. Maybe I'll take one more step and I'll just multiply that whole number out. It's just 27 with 3 zeros behind it. And how do I show that this is the number 3? Well, how about let's bring in a base. So this whole time I've been saying with the change of base rule, you can choose any base you want. And I think right now 30 is going to be the best base to choose. In the bottom, this is kind of asking how many 30s do I need to multiply together to get to 30? And that's just going to be, well, one of them. And then in the numerator, if I can show that 30 times 30 times 30 is the same as this number, that is the equivalent of saying that log base 30 of 27,000 is 3, because I've shown that 3 30s multiply to this number. And doing the multiplication here, we can just get all of the 3's all together. So 3 times 3 times 3 is 27. And then the zeros I'll tack on at the end because I'm kind of multiplying by 10, 10, and 10. And this shows that log base 30 of 27,000 is 3. So overall, using that change of base rule and then picking a maybe clever or useful base shows that the number is just 3 for our answer today. So there we go. The number's 3. That's today's date, and we're all done. I'll see you tomorrow. All right, bye.